Hello, SirParts online subscribers, and welcome to SirParts I Teach, wherein we're going to learn machine learning in W3 schools. So, thank you very much for being here in our video. And, guys, please do not forget to subscribe, like, and ring the bell so that you could get the latest videos of SirParts online. Okay, so let's go. So we're here again in our website in W3 Schools, and we are learning scale. So in the previous video, we have the multiple regression, and right now we are going to study about scale features. Okay, when your data has different values and even different measurement units, it can be difficult to compare them. What is kilograms compared to meters or altitude compared to time? The answer to this problem is scaling. You can scale data into new values that are easier to compare. So take a look at the table below. It is the same data set that we used in the multiple regression chapter. This time, the volume column contains values in letters instead of cubic meter. 1.0 instead of 1,000. So there is the table, guys. No, Toyota Aygo, 1 liter for 790 weight. Then the carbon dioxide is 99. So it can be difficult to compare the volume 1.0 with the weight 790. But if we scale them both into comparable values, we can easily see how much one value is compared to the other. So there are different methods for scaling data. In this tutorial, we will use a method called standardization. The standardization method uses this formula: Z equals x minus u divided by s, where z is the new value. I guess this is the z-score, guys. X is the original value, u is the mean, and s is the standard deviation. If you take weight column from the data set above, the first value is 790, and the scaled value will be 790 minus the mean 1292.23 divided by the standard deviation of 238.74 equals negative 2.1. So if you take the volume column from the data set above, the first value is 1, and the scaled value will be minus 1.61 divided by 0.38, that is equal to negative 1.59. Now, you can compare negative 2.1 with negative 1.59 instead of comparing 790 with 1.0. You do not have to do this manually. The Python sklearn module has a method called standard scalar, which returns a scalar object with methods for transforming data sets. Okay, so we have here our code for that. Scale all values in the weight and volume columns. Import pandas. From sklearn, import linear model. From sklearn, that preprocessing, import standard scalar. Scale equals standard scalar. Then we have df equal pandas.read csv data.csv. Then we have x, capital letter X, guys. Let's take note. What does it mean, the capital letter X? Okay, you're right. The capital letter X, it's capital letter because it is the independent variable, the weight and the volume. And in our previous example, the y, the small letter y, is the dependent variable. Okay, scale x equals scale fit transform x. Then we're going to print the scale dx. So this is the result. The first value is are negative 2.1 and negative 1.59, which corresponds to our calculations. So we can run our example here. Okay, so just click that button and you will have the run. So this is our data.csv, guys. We have a CSV file is comma separated value. So we have here car, model, volume, weight, and CO2. The car is the what you call this one, the element of our data set or data table, while model, volume, weight, and CO2 are our variables. Okay, so let's go to the Python code. So import pandas. This means that we're going to import pandas. We're going to use this in our program. Then from sklearn, import linear model. So we also use linear model coming from sklearn. Then from sklearn that pre-processing, import standard scalar. And we have here an equation scale equals standard scalar. So df, we have a variable df here, which is equal to pandas.readcsv. And this data.csv is the data that we have right here. Okay. After that, we have the capital letter X, that is a variable. This particular variable is an independent variable. We have for weight and the volume. Okay, so scale x equals scale fit that transform x. So we're going to transform, we're going to scale the values from the weight and the volume of our data.csv. And after that, we are going to print the scale x. And these are now at your right. You can see this block. This is our output, and that's the result, the value of our weight and our volume. Okay, so that's the scaling. Okay, next topic for our scale is predict carbon dioxide values. The task in the multiple regression chapter was to predict the carbon dioxide emission from a car when you only know its weight and volume. When the data set is scaled, you will have to use the scale when you predict values. So here, for example, predict the carbon dioxide emission from a 1.3 liter car that weighs 2,300 kilograms. So this is our code. Import pandas from sklearn, import linear model. From sklearn that pre-processing, import standard scalar. Scale equals standard scalar. So you just need to copy this one. Then we have our df, which is our variable storage for our CSV, pandas.readcsv data.csv. And we have now our capital letter X, which is equal to the weight and also the volume of our df. And also the value of our y for our df in our data.csv, no, for the carbon dioxide. And after that, just a question, no? What do you mean by capital letter X? Why we need to capital that letter X? Okay, we call that's a standard. That means that that capital letter X is an independent variable, and Y is the dependent variable. Okay, so let's continue. Scaled x equals scale that we transform x. So after that, we transform our weight and our volume. Then we have reg R, linear model, not linear regression. So we are having a linear regression here. Reg R fit scaled x, the new value of our x, and the y. Then after that, we have a new scaled, which is scale the transform 2300 comma 1.3. This is now our prediction. This is our prediction that 2300 here, that is the kilograms, the weight of our kilograms, and 1.3 from the 1.3 liter car. Okay, so then we are going to have the predicted CO2. We use the value, no? We use the value of the scale, the first value of our scale. And the result of that is this one. Okay, 107.208. Okay, so let's run the example. This one, yeah, that's the answer. So if we change the value here, we can change the value for our prediction. It's either here and also here. So let's say, for example, if you want to have a 2,400, 2,500, 2,500, then this is 1.2. And if we're going to run this, it will produce another prediction. Uh, what happened, guys? Okay, we were able to delete. Okay, let's try to run again. Okay, the answer is 107.938. Okay, thank you very much, guys. We are about to end with our topic scale. So I hope you learned something today. Please do not forget to like and subscribe so that you could get the latest videos of Sir Parts online. Thank you very much for watching in our series Sir Parts I Teach Learn Machine Learning in W3 schools. Bye everyone. Always remember learning is lifetime.